Yeah, let's get to it. A few words about myself. My name is Peter Friedrich. Currently located in Columbus, Ohio, in our office in the States, and I take care of I took care of most of the activities in the US, but now we have a bigger team here. And today I want to give you a demo of the modeling part or model management module. I'll try to handle this a little bit based on a couple of use cases here. They might be a little bit simplified from what you actually encounter in your day-to-day work, but I hope they're good enough to demonstrate some of the features, some of the approaches, and some of the philosophies that we use with the SCALE.sdm system here. I probably won't have the time to go over every single piece, especially of the user interface and the all the buttons, all the different features. So if you have anything that you want to know more about, please raise your hand here, and then we can add you to the conversation. Also, just wanted to remind you, if you want to take part in our survey here, maybe Marco, Akbar, do you have the slides handy? Can you put the code in the chat here?
Yes, I will do.
Thank you.
I will do.
And
Peter, what the participant can also do, they can always write into the chat, and we'll answer it alongside.
Oh yeah, of course. Yep. Yeah, so we'll try to answer your questions while I'm speaking, but also if you have anything that's it's not easily expressed in text, then feel free to raise your hand. All right, then let's get right to it.
I'm sorry, just Peter, just to make it interactive, if you raise your hand, I mean, and you want to just ask question live, that would be okay also. But yeah, it's up to you. All right, thank you. Sorry about that.
Yep. Okay. So yeah, let's get right to it. I hope you all see my screen by now. What I'm showing right now, that's the basic user interface of a Scale model. So that's what you see when you start the desktop client. As Marco described, the system itself is cloud native, but for interacting with your model, especially doing editing model parts, doing setup and evaluating results, you still kind of want some kind of desktop component here. So our desktop client is the main gateway to all the model management of SCALE.sdm. The desktop client itself, runs on Windows and Linux, and all you need is just a network connection to the server component, and then you can basically work from anywhere in the world. Might that be a local workstation or a laptop, or even remote graphics solution like Citrix Citrix Workplace, I think, or a different remote graphics solution that you might have at your company. Just to go over a couple of the basic UI elements here. See on the left side, I have my full version browser here. I'll get into a bit more detail what that is later. I see the structure of my model here in multiple groups that are all customizable and depend on your modeling needs. And then at the bottom part here, I see my different load cases. So each of those represent a specific load case and an associated simulation I can start. In the big middle part that's displays all the information about your actual includes or your model parts. So every line in this table is a separate solver include, for example. Could also be a script that handles some part of the logic for simulation or post-processing, or it could be parameter values that manipulate the simulation. And then in the individual columns, there's a lot of metadata attached to each one of those, and we'll take a look at what that means a little bit later. On the right side here, the way I arranged it gives me again small glimpse at the history of whatever I selected. So the right part here reacts to whatever I select in the middle. Gives me more information about the actual selection here. So who edited it, when, and a lot more details. And on the bottom here, at the bottom, I see my job management tab. So in addition to just model management, we also handle the submission to HPC clusters. And this is basically a status window of what's going on with the simulations I started. Has an entry for every job I'm running. Currently, there's one that I started earlier that's currently running LSDyna here. And I can also dig deeper into the details of what's going on here. As I said at the beginning, the basic building block here is the pool and the pool version. So right now, the project I'm showing, that's our in-house demo project. It's a LSDyna model or a crash model of a Toyota Yaris. And this pool, this Yaris pool, that contains all the include files, the entire history of that project, every single change that was made by different team members. All that information is contained in this unit. And everybody who gets access to the system first and who gets access to that specific project. So there's a granular permission system there. Everybody who gets access to that has also access not just to the current state of the model, but to all the intermediate versions, all the history, every change that was ever made. And the way to interact with that, just to make this a little bit more graphic, if I can take a look at the entire history of the project here. I will take a couple seconds to actually build a view because there's been a lot happening here lately. And this basically gives me a gigantic graph of the progress in this specific project. So every rectangle here represents a single pool version, what we call a pool version. And this is the entire simulation model in a specific state. So if I go back to maybe a version that was created a couple of weeks ago, I can see the exact state that model was in at the time. And I can take that as maybe as a baseline, as a starting point for whatever I'm trying to do. But the history itself will always be preserved. You see also those the lines connecting those versions here. That's basically the parent and child relationships between those. So if you look at, just to make this a little bit more readable here, this is a version I created yesterday, and from this I started to do 2 different iterations here. And again, since they are their own little silos for the model here, every change I make within this version does not affect anything else. So other people can work in parallel with me. We don't interfere with each other. But once you're finished, once you're done with all your changes, you can make those changes public, and other people can either use it directly, build their versions on top of it, or they can just use bits and pieces of that and preserve the entire history here as well. And in this state here is quite unmanageable, to be honest with you, but there are different ways to filter here. So for example, if I want to only see versions that were created by a certain colleague of mine, then I can search for their name. And I only see what they created over time, and I can jump directly to what they did. If they left good commentary on their changes, then I can also kind of replay what the history was and what they were working on. Different way to filter here would be by different tags. So for example, if you want to follow your baseline versions, so maybe you have you combine all the different changes in periodically, then you can mark those as snapshots basically in your history. In our demo environment here, we're using this reference. So if you see this little green R here, that means that this full version, this model state, was marked as a reference version at some point. And so it's easy to search for those. And if any team member wants to create a new iteration, they maybe they're new to the project, they want to know what is the current known best version of this simulation model, they can search for this tag and then just use the latest one. So that's a way to make it easier to collaborate, maybe reduce the amount of written communication or emails that have to be sent if you have a system in place that uses some conventions. You can make a lot of those tasks a lot easier. Okay, so now I actually want to do something here, and the example I picked here is I want to basically evaluate two different variants of the same model part. So I want to set up basically 2 different simulations based on my current baseline, and want to run both of them, and ideally want to compare the results. We won't get to the comparing the results part because simulation takes time, but at least we can do the setup. I have 2 different ways I want to show you how to do this here. So let's just get started. First thing, and I already did that, I want to pick my my baseline version. This is 2480 here, which I prepared beforehand, but this could very well just be from somebody else or from a milestone at some point. Then the part I actually want to edit today is the hood. So I navigate to this group here, doors and lids. Since there are so many includes in this crash model, we categorize them into different. Like you can think of it like a folder structure basically, and this is customizable, depends on your project. So whatever you like, whatever maybe you already have some kind of structure that you usually adhere to, then this could be replicated here just as well. So I'm going to navigate to the include I want to edit. This is my hood include here, and this single line represents that include. If I select that, I see my little 3D preview window up here. So it is indeed a hood part. I can also check maybe I want to know who edited last. So I see this owner here at the end, Marvin, and the date modified was in beginning of April last year. And now I want to open that in the preprocessor and make some changes. As Akbar mentioned at the beginning, we are solver agnostic and in general open to integrate any kind of pre or post processor that you're already been working with. For this demo here, I'm going to use Beta CAE's ANSA as a preprocessor, but any preprocessor you already have is usually just a script away. Most or quite a few of them we already have. ANSA, a primer, HyperWorks. For those we already have integrations, but everything else is usually pretty easy to integrate. So I'm going to open this in ANSA, and I hope that Zoom doesn't slow my machine down too much. So I actually get that open in time here. You see that while I'm opening this, I get this a new view here. Basically, it's just giving me like a staging area. So I'm not making changes directly to the source version I had. As I said, those are the point is to preserve your changes. So what I'm actually doing is I will create a new model state based on that one without changing the original. So at the end, you have both of them, and you can that way you see the evolution of the model. On the back end, that actually doesn't copy anything, so you don't have to be worried about saving each individual include hundreds or thousands of times. But from the application perspective, it looks like it's actually a separate include here. Okay, so what I'm going to do is just very simplistic, just going to delete a couple elements here. Right. Basically making some change here. Also, just a side note, this include actually only has the nodes and elements here for the part. But in this answer session, I also get all the materials that are in the project. So there is some logic for and those material includes also to be loaded into your answer session automatically. You could also open multiple includes at the same time and get them all in the same answer session. So there's a lot of integration there already. Right, so I made my change. Now I just want to save and quit that. This little toolbar here comes with our answer integration and just automates some of the export tasks. Then I click that and get back to this interface here. But it's basically telling me, okay, so you opened this hood include, you did make a change, and now it's asking me to describe what I did. So I'm going to write a comment here, delete some elements for the demo, and then I can apply that change. All right. So remember we started with 2480. That was my baseline version. And now you see this little line coming up here from my baseline, and 2484. This is my new version that I just created with that change. And this actually only has this changed hood. Everything else is just taken from 2480. But again, this gives me like an isolated environment where I can make any changes, kind of like just taking a copy of the directory of the model, but without actually copying anything. Okay, so I made my change to the hood here. And now what's also triggered here in the background, let me actually make sure that it's ran here. It will also update my 3D preview. I hope we actually see the deleted elements in there, but that's kind of all part of the workflow. A lot of those things are like off-the-shelf scripts we have for all the solvers we've been working with, but most of the features can be adapted to any solver, any environment, any specific needs or asks you might have. All right, so I have my first version, and maybe I got a second hood from a colleague, maybe from a supplier, and that's what I want this compare this to. So I want to create a second model with this different hood. So I'm going back to my reference version here, going back to what I had before, and now instead of making that edit myself, I just want to replace it with a component I already have in my on my hard drive, or maybe I got sent to through some kind of file transfer service. Going to do this a little bit differently, so I'm going to purposely create a new model version here first. The way you do this is usually there are usually a couple ways to go about these things. Some are just equivalent, some have their different nuances. So the result is the same here. Also just set comment here. And then I want to replace my my hood include here. So I'm going to choose replace instead of edit. That drops me down to a file manager, and I'm going to pick this file that I got here, open this, and it will replace the contents that I had before. All right. Okay, so now all that needs to be all that needs to be done is to actually start simulations. So I have my two pool versions, so I can look at the load case I want to submit, and here you might notice that I actually didn't have to create any new load case or any master file, any deck or anything. Just by using my reference model version, all those load cases are already set up because they've been used before. And whenever I make changes to my model, this will just use the updated versions of those individual components. So we look deeper here. I have different load cases for different regulations. Again, this is all crash safety specific here, but could be anything. and each one of those entries represents one specific simulation, selections, or collections of what we call attributes. So look at this name here, or Euro NCAP, pole left 90, 29 kmh. Those are all descriptors to select the correct model parts. So just to follow one of those, if I go to my barrier includes here, that should be rather easy to see. All the barriers are also part of my my pool version, my model state. I'm just going to change the view a little bit here. Okay, so now we have what you see here. This is all the barriers we have in this project. And you see them highlighted in red and green. Red would be everything that is not part of my currently selected load case, and green is everything that is part of my currently selected load case. So if I'm selecting the Euro NCAP pole here, of course I get the pole barrier. But if I change that selection to the Euro NCAP rigid wall, then you'll notice that this actually changes. And now I have my rigid wall component here. For the barriers, that's just an example. It basically works like this for every single part of your model. We have a couple of those attributes. Basically, all the ones you see here are the ones we have defined in this case. But this is all very customizable. So whatever selectors you have to differentiate between different load cases, between different model variants, maybe different trim levels, all this will be captured as attribute values. And then instead of having to manage which includes are part of each simulation for all your different load cases, you just define on your component, on your include directly, this should only be part of a load case if my barrier attribute is set to this value here. And as long as you build this kind of logic, it is very easy to scale up to dozens or even hundreds of different load cases without having to duplicate any of the include files or having to manually edit them for every load case.
Peter, can I interrupt you here?
Mm-hmm.
There's a question in the Q&A. Can we text edit and include file and then save?
Yeah, sure. So I kind of took the porcelain way to edit includes, but of course you also can use any kind of text editor. So if I just go back to my example here, just want to jump and go back to this edit menu, then I also have a bunch of text editors set up here. I have a GBIM, VS Code, or my personal favorite, Emacs here. So I can just edit those files as plain text files. And then this works without any further integration. As long as your application is able to open a file and save it to the same location, this is basically just a configuration field away to get any text editors you want. So you can make any change you want here. And then save that file, close your editor, and then this change is applied just the same. Okay, so I now actually want to submit some jobs here. Let's see. We'll actually see if those go through. There might be some issues because we at least when I tested something earlier, there was a part of the process that required some limited license here, but I'll just go through. I want to do this Euro NCAP rigid wall here. So I select my load case. I have my model version selected here, 2484. And then I can, I have two different options. If I go to the left, to the right, to my properties here, don't want to worry about any of the settings here right now. I have the option to assemble this model locally on my local workstation, which basically just means it will pull all the data together, download what you don't have, and then build your master deck somewhere on your local machine. You can also run some scripts then and there, but usually that's used for like evaluation purposes. If you just want to give it a quick look, then you can do that locally. More often than not, you want to actually send your job to the cluster, and that's also just one button away here. So if I click on this, it will submit that job to our internal cluster. And in a minute or so, I will get an entry in my jobs history. So right now I see it's still submitting this job, doing some local tasks here. But as soon as that's done, I'll get some feedback from the actual cluster, and I'll do the same for 2485 here. So switching pool version, that means now whatever I do uses the other state or the other version of my hood here, and I can just submit the same load case just with the different hood include, just the same. Click on remote assembly here, and then wait for the cluster to pick that up. All right, while we're waiting on cluster to do something here, Marco mentioned earlier the check capabilities. You might have noticed that there is a check mark here next to each of those entries. And this is actually the visualization for our model check specifications here. So you see the green ones, they were checked previously, and they have passed all the checks. So if I select this hatch here, back. If I select this hatch, I can take a closer look at what actually has been checked. So I have this checks panel in the properties, and I can see we have what we do is a data check just with that include, and that has been working fine. There are no solver errors here. We also extract the component mass for that include, and then we do a check for numbering conventions. So all the parts are in their respective ranges. This is, again, that's just our implementation of those checks. The infrastructure is there. If you have, of course, that's very specific to how you want your models to be built, what kind of requirements you want them to meet. So all of this is also customizable. If you already have some mechanisms there, they're fairly easy to plug in. Or if you want to develop something from scratch, we have some examples, some best practices maybe, and then you can go from there. In my new part here, it looks a little bit different. I get this gray checkbox here because there was a check result, but then I changed the component. So those results are actually not valid anymore, or at least we can say. So it gives me this gray checkbox. And what I can do here is I can launch this check by using check component here in the context menu. And this on the back end will also actually launch a job on our cluster that only does the data check and then feeds the results back into my SDM client here, so that I and everybody else looking at this gets the results of those checks. And it looks like my first job here is just started. So I want to dig a little bit deeper into what this window here gives me. Those are all the feedback that was generated by the integration scripts for the simulation process. All the scripts are also part of my model, just the same as the includes. So if I have an entire subfolder here with tools that grew over time quite a bit, to be honest. But this has all the plumbing to actually get something to the cluster, maybe have some automated pre-processing steps, post-processing steps, all that, session files for post-processors, all that is also captured here. And those scripts can give me some output while they're running so that I can see what is currently going on, down to basically seeing where my simulation is at. So with the dyna, I see which time step it's currently on, just to get a feeling for how long I might have to wait for results. And all this, again, is also very customizable. We have a couple of building blocks for some common environments, I would say. But everything is possible. Integrating scripts you might already have is usually a good way to start, and then kind of just go from there. All right. Are there any questions until this point here? Wanted to check in for a little bit, because I know I'm probably skipping a lot of things here, especially since the user interface, there's a lot going on, but I just kind of want to get to the interesting bits. So again, if there's anything I should or I can elaborate a little bit more, just let me know.
Yeah, thanks, Peter. That's a very good pause. As we have a few more minutes before we take a break, as we wanted, this is not only webinar. It's just more interactions. Obviously, you don't have a control and you don't have a product in your desktop. Hopefully, we'll do that, in the continuation of the working with you guys in your company. But if there are any questions, anything that maybe you like to emphasize, or Peter can go back and emphasize on those pieces, or anything, because especially this is right now focusing on the crash and safety, and I know maybe you have some other interest in the different attributes, and maybe we can answer those questions if you want to raise your hand, or we can just Peter to just wrap up this model before he wraps up the model at 2 o'clock.
Okay. So I got a question from Roz. I can elaborate on the different status of pool versions. Thank you for the hint here. I don't think I actually ever mentioned that yet. So that's definitely very important. So if you look at this history view up here, so basically it kind of gives me a chronology of the different versions. and you see there's different icons to the left of those version numbers. So basically we have 3 main types of pool versions, or 3 main statuses that a certain model state can be in. The easiest one is the public version. And everything that's marked with a check mark here, those are public versions. What that means is the term public might be a little bit misleading because it's still, it's of course only accessible to people with access to that project. But what it means is everyone who has access to the project can look at those pool versions, at those models, can use them as a starting point for new versions. But, and that's very important, those versions cannot be changed anymore. So this version 2480 here, which is public right now, this will always be in that state, no matter what happens. So there's no way to make any changes here. So if you reference this version number, maybe in a report somewhere, maybe you have simulation results that mention that version number, then you always know that if you look back at this version right now, it will be in the same state it was whenever you compiled that document. The second state here is actually denoted by 2 different icons based on situation here. So it could either be those lines you see for everything that's in boldface here, and that means my version is private. What that means is it has a clear owner. In that case, that's me, and I can make changes to that version. I can make changes to that version as long as I want. And if I want to preserve that for the future, I can set my version public, and from that point on, it will no longer be changeable. While the version is private, I myself can look at it, and certain users with elevated rights, so project managers usually can also see what's going on in my version. That's just important in case someone is on vacation or is not available. Then it's kind of a last resort to look at their private versions. Everybody else can only see that there is a version, but they can't do much without it. They can't do much with it. So from the other side, from a different user, those look like this cross symbol here. So those are also public. Those are also private versions, but they belong to a different user. So I myself can look at them because I have elevated rights here, but I can't do much with them. I can't make any changes, and I can't use them as a starting point. It's kind of just like a working directory for somebody else. And the last type of versions here, that's a little bit different. You see, this has this circle icon here. This is what we call a live version. It's kind of a hybrid between private and a public in a way that everybody can make changes to that version. So everybody can just access that version and make changes to it. But there are some restrictions because multiple people can edit it. We have to make sure that there is no conflicts going on. So whenever I'm opening any include here, this will actually be logged for everybody else. So unless I finish my editing process, finish my change, nobody else can open the same include. But as soon as I do, it's kind of open again, and then other people can make changes. This is kind of helpful to collaborate on just a single version. And then just the same as with the private version, if you want to persist that for the future, you can set this public, and then from then on, all the changes are not modifiable anymore.